Um, oh, okay. You're live.
Okay. Okay. Good afternoon, everyone. Today edition of our lesson, we will look at volume and total surface area of a solid figure. The last time we looked at a plane figure, but today we will try to look at volume and then total surface area of a plane figure. Okay, so when we say a plane figure, what is it? Let's look at this diagram. So this is a solid figure because this is a solid figure. This is a solid figure. Because we have three dimensions. We have the length, we have the width, and then we have the width, and then we have the index, that's the height. So we have height. So solid figures are in three dimensions. But the last time we were told that plane figure, we have just a flat surface. We have these two dimensions. That's the width and then the breadth. So when you pick, let's say, example, this book is a solid figure. This book is a solid figure. So we have this space and then this and that. So this is the height. When I place the book like this is the index, the depth of the book. This is the width or the length, and then the shortest side is the width. So that's what we are coming to discuss. So first of all, since we know what a solid figure and a plane figure, we will concentrate on what a volume and a total surface area. So the motivation behind what we are doing is, why are we finding volume of a solid figure? So the idea of finding volume for a figure is we are trying to look at the total space that is inside that particular solid figure. So when you look at this box, this shop box, you could realize that you have a space inside. So you are trying to look at the total space inside this particular job box. So that's what a volume is. So volume, you have this. So volume is basically we are looking at the total space inside the solid figure. So how can we find the volume of some solid figure? By then, what are some examples of solid figure? So you have key, you have keyboard, you have cylinder, sphere. All those objects are solid figure. So let's take this example, the key. So what we know about key is that all the sizes are equal, just like squares. So we have series of squares putting together to get a key. So this side is equal to this, and is equal to that, and is equal to this. So when you want to find the volume of this, you multiply this. Let's say this is A by this side and by the depth. But since it's cube and all the sizes are equal, we try to represent them with the same variable, say A. So this one will be A, this one also be A, and then the height will also be A. So the volume is multiplying this by this, and that will give us the volume. So V, so volume, let's say V, the volume is equal to A times A times A. But don't forget the units. So let's say this one we are measuring in centimeters. So we have, so let me attach the units so that you can see. So we have A centimeters times another A centimeter, or centimeters times another A centimeters. So we have A times A times A. Since the bases are the same, by the law of indices, you add the exponent, and each one has an exponent of 1. So when you add, you have 1 plus 1 plus 1, which is 3. So we have A cube. And these ones, they are also the same, centimeters. So you have centimeter, centimeter, centimeter. So when you multiply them, you get centimeter cube. So you have centimeter cube. So that's why volumes are measured in cube. So volumes are measured in cube. So if it's centimeter, you have centimeter cube. If it's kilometer, you have kilometer cube, meter cube, and so on. So that's basically about key. So let's look at keyboard. Keyboard. So keyboard is a combination of these rectangular shapes to get our keyboard. So we have this figure to be keyboard. Let's assume that this keyboard is how it looks like. I don't know how to. There is a keyboard. So this is a keyboard. So this keyboard. So we have this one. This one rectangle. There's another one rectangle. Another one. And then other side, opposite other side. So if I should draw these lines. So this one opposite. So at the end of the day, we'll be having 6 sides or surfaces. So to find the volume is the same as this cube here. But here the sizes are not the same. So I'm going to represent them with different variables. So let's say the width is A, then the length is B, and then the in-depth, that's the height, is say C. To find the volume, we multiply the size. So you have 8 centimeters times B centimeters times C centimeters. Okay. C centimeters. So with this, you can see that A, B, C, they are not the same. So you have to write it. So A times B times C will give you A, B, C, all times A, C, centimeter times centimeter is what? Centimeter square times another centimeter will give us centimeter cube. So at the end of the day, you realize that your unit of measurement is in cube. So this for keyboard. This for keyboard. Okay. So now let's look at other plate figure. Like our cylinder. Okay, let's take one more volume. Cylinder. I think I should put it together. So this one is cylinder. So what do you think will be the volume of a cylinder? So what do you think will be the volume? Any idea? So when you look at this cylinder, you can see that you have two circles at the end points. So you have something like this. This one circle and this another circle, right? And then the height, the literal height, is in the form of, let's say, something like a rectangle. This is how the cylinder looks like. So when you enclose this, you have your cylinder. So what would be the volume of a cylinder? So the volume of a cylinder is basically just like a rectangle. You have this one. So the whole of this becomes, let's say, your width. And then the edge becomes your length. So what is the width? The width is the area of a circle. And from the previous lessons, area of a circle is what? Pi r squared. So we have this pi r squared, which happens to the area of a circle. And then times the length. The length here is now the height. So times h. So the volume of a cylinder is giving us pi r squared h. So that's why we had this as a volume of a cylinder. So it also works for other solid figures. So basically what you have to put in mind is various nomenclatures of these solid values or solid figures. So that's basically what a volume is. So now let's look at what a total surface is, so that we can pick one or two questions. So now let's look at what a surface area is and why are we interested in finding the surface area. So surface area of a solid figure. So why are we finding the surface area? So the idea of finding a surface area is, let's say you bought this fine object for a friend, and then you need a wrapper to cover the outer parts, to cover everything so that the person will not see what you are presenting. So you want to know the total amount of wrapper or paper that's required to cover everything. So that is basically about total surface area, right? So that's why we are interested in finding total surface area, so that we will not waste money and buy things, and at the end of the day, the rest will be in waste. So total surface area is just, we want to find the total area of this object. Total area of this object. Or total amount of wrapper required to cover everything. So we have this keyboard. So let me use this box as an example, because this box, let's say, is cuboid. So we have this. So for me to find the total surface area of this particular box, it means I have to get this area plus this area plus this area plus this area, and then they find the area of this side as well, and then the area of this side. So if I'm able to add all this, then I have a total surface area. So for me to know the amount of wrapper that I may need to cover all these blocks, then I have to find this area plus this area plus that. So this is how it looks like. So we have this solid filler, which I assumed to be square. So let's say this is a square. Okay, so we assume that this one is a square. It's not perfectly drawn to scale, so let's assume it's square. So what is the nomenclature of a square? We know that squares, all the sizes are equal. So first of all, let's label the total surface of this object or this cuboid. So you have one here. You have the whole of this to be 2. So this side is 2, this side is 3, and then each surface has its opposites. So one will have its opposite down here, let's say 4, and then 2 will be at the back, let's say 5, and then these 3 will be at this side, so 6. So in all, we have 6 surfaces for this cuboid, like these troubles. We have this and that, this and that, this and that. So what we have to do is you find one area for area of one surface. So we have this. Let's say this one. So what will be the area? Since it's square, if this length is A, this is also A. So at the end of the day, the area of one surface will be equal to A times A centimeter squared, which will give us A squared. So for a cube, area of one surface is A squared centimeter squared. A squared centimeter squared. So at the end of the day, when we have to find the total surface area or total amount of wrapper that we may require, to cover our box, then you have to add each surface area. So we have A squared centimeter squared plus another A squared centimeter squared plus A squared centimeter squared plus A squared centimeter squared plus A squared centimeter squared. Since P has 6 faces, we tend to add all the faces. Okay, so at the end of the day, we have how many A squared centimeter squared? We have 1, 2, 3, 4, 5, 6. So at the end of the day, we have 6 A squared centimeter squared. So this is the formula for finding a total surface area of a cube. Okay, so the same idea will help us to find for a cuboid. So what is the nomenclature of a cuboid? A cuboid is just a combination of, it's just like a cube, but this one is in rectangular shapes. So we have this. Let's say this is the first face. This one, the first face. Then there is also another face. Okay, I'm going to scale. There is another face, and each face so let's say this cuboid. This cuboid or any rectangular solid shape. So with the same idea, what we do is we find the area of this surface. Area of this surface. And then so the area of this surface is the same as the area of this surface down there. And then this one will be the same as this. Just like the keyboard. So let's say this one is a rectangular solid shape. So the area for this surface is equal to this. And then the area of this surface is equal to this because it's in a rectangular shape. So at the end of the day, let's say this my width is A, length is B, and then the height is C. So at the end of the day, I'll be getting, let's find the area of this surface first. So this one will be A times what? C. Since it's a rectangular shape, this is equal to this. So the first part will be A times what? C. And then this one is equal to the opposite end. So the same thing. A times C. Okay. Plus, then let's move to this guy over here. So the length of here is equal to B. So we have B times this. And this one is what? A. So at the end of the day, we have what? B times A. And this area is equal to its opposite side. So plus another B times A. And then the last one has to do with this end. So this end have B times what? C. And then it's equal to its opposite side. So we have another B plus C. So since this term and this they are the same, we can add them. So at the end of the day, we have 2A times C is what? AC. So 2AC. Plus this one BA plus BA is what? 2BA. Plus this last term, BC plus BC will give us 2BC. So we can further simplify this since we have 2 to be common. So we have 2 into brackets AC plus BA plus BC. So this is the formula for finding total surface area of total surface area abbreviated TSA. So this is how we find total surface area. So anytime you have a question, what you have to do first, read the question, try to draw the figure in question, and then locate what you are looking for, and then put down the formula, and then you are good to go. Okay, so let me take you through one additional solid figure so that we can pick 1 or 2 questions and call it a day. So let's look at a cylinder. Look at a cylinder. A cylinder is also another solid figure. A cylinder. So the total surface area of a cylinder. So this is how a cylinder looks like. I have this. So cylinder comprises 2 circles at the top and then at the base, like the bottom. Something like this. And in between is in a form of a rectangular shape. So let's assume we have this in between. So this radius, this the height, then another radius R. Then this is the vertical height. So with this is the same thing. So you have 2 circles at the end. So what you have to ask yourself is, you want to find the total surface area So the total surface area has to do with, you find the area of this uh, space here, and then area of this, and then the area of this, and then you add them together. So at the end of the day, you get uh, that results as our total surface area. So first of all, you all know area of a circle. Area of a circle is equal to pi r squared, right? So we have this area of a circle and then another area of a circle. And then we have this slant height. So we want to find the area of this side, the folded part. So what will be the area of the folded part? So the area of the folded part is simply, you see, the total length of this times height. So the total length of this becomes our width if you are dealing with a rectangular shape. And then this one is what? Our length. Length. So this width, and then let's this assume to be the width. So the whole of this, because when you fold this, you'll be getting something like circular. So that's why we are finding the circumference of this. So circumference of a circle give us, so circumference of C, that's a circle, is what? 2 pi r. So at the end of the day, we have the total length of this times this length. And this length is what? The height of our cylinder. So when we put everything together, then we have the total surface area of a cylinder. Okay, so now let's put them together. So total surface area of cylinder. So we have the two areas for the two circles. So we have pi r squared plus the one at the bottom also pi r squared plus, so this one, to find the area of this is the width, which is also the circumference of the circle, times the length, which is the height of the cylinder. So at the end of the day, I will be getting 2 pi r h. So this can be simplified further. They are the same, so we have 2 pi r squared plus 2 pi r h. But we can simplify this one to again by factorization. You have 2 pi r, they are common. So you have 2 pi r, bring that one outside the bracket, the remaining one of the r plus h. So this is total surface area of a cylinder. Okay, let's pick one example and then let's see how these things work. Okay, this actually is a past question. Class B is A. This is one of past question. I think 2014 or 15 thereabout. So a cylinder which has a height, a cylinder which has a height of 90 centimeters and diameter of 14 centimeters, closed at both ends. So these are following account. So the person reads like A or I, find the total surface area. So the total surface area can be also put in a different form. They can give you word problem scenario, and then they ask you what will be the total amount of paper or wrapper that may be needed to cover this cylinder. So it's the same as the total surface area. So it's not always that you'll be getting a straightforward question like find the total surface area. So you have to bear those things in your mind. Okay, so the next question says we should find the volume. So I find the volume of the cylinder. This cylinder. Okay, so this is our problem of the day. So how are we going to solve it? Okay, so with what we've gone through, the first step is you read your question or your problem. So you read and then you draw. So a cylinder which has a height of 90 centimeters and a diameter of 14 centimeters and close both ends. So first of all, after reading the question, then we draw our figure. It says a cylinder. So this is how a cylinder looks like. So these are cylinders. And then after drawing, use the information given. Use the information given. So we have 90 centimeters height. So this is the height. So this is our 90 centimeters. Okay. And then the next one is the diameter. You know the diameter is from here to this point. So we have 14 centimeters. So to find the radius is half of the diameter. So the radius will be something like this. So these are the radius. Okay, so the next question is, what are you looking for? That will be your next step. So the next step is, what are you looking for? What we are looking for is the total surface area of this object. And then we know the formula for total surface area of the cylinder. So this is our first. Okay, so let's take this one. This circle. So radius is equal to the diameter divided by 2. So at the end of the day, we have 7 centimeters to be the radius. So total surface area TSA is equal to the area of this plus the area of this plus the area of the folded part. So we have pi r squared plus another pi r squared, being the same as 2 pi r squared plus 2 pi r h. So this is the formula for total surface area of the cylinder. So after writing down our formula, then we substitute the information given. And one thing that you have to note is, when pi is not given, we assume to be 22, so we take pi to be 22 over 7. Okay, so total surface area, so TSA of the cylinder will be 2 times 22 over 7, which is the pi times r squared. R is what? 7. Plus 2 times 22 over 7 times 7 times the height. The height is 90 centimeters. So times 90. Okay. So at the end of the day, let's simplify. So let's pick this first one. So we have this and this. So one of the 7s here will cancel this. So at the end of the day, we have this 2 times 22 times 7. Centimeter squared plus this 7 will cancel this, so we'll be getting 22 2 times 22 times 90. Okay, so let's simplify 10 by 10. 2 times 22 will give us 44 times 7. So we have, so let's put here 44 times 7. 4 times 7 will give us 28, 8 under 2. 4 times 7 another 28 plus 2, 8. So here, the first time we had 308. Plus, let's look at the second term. The same 44 times 90. So 44 times 90. So 44 times 90. 0 times 4, 0, 0. 9 times 4 is 36. So 6. Remember 3. Another 36 plus 3, 39. So when you add them, you have 0, 6, 9, 3. So we have 3960 centimeter square. So when you add these two things, then, so let's bring it together. So we have 3960 plus 308. So when you add, we have 8, here we have 6, here we have 12, 2 and 1, 4. At the end of the day, we have 4268 centimeter cube. It's square. So this is the total surface area of the cylinder. So this is the total surface area of the cylinder. So now let's look at the second part of the question. The second part. The second part says we should look for the volume. So you ask yourself, what is the volume of a cylinder? A volume of a cylinder. So volume of a cylinder is V, which represents volume, is equal to pi r square h. And then you substitute your information given. So we know pi to be 22/7 times the radius, we had 7 square, times the height, which is 90. So one of these 7 will cancel this, so you have 22 times 7 times 90. So let's break them down. So 22 times 7. So 22 times 7 first. So 22 times 7, 2 times 7 is 14, the 1, another 14, the 1 plus 1, 15. So we have this variable, 154. And then 154 times 90. So now let's do that. 154 times 90. So 154 times 90. This 0, 0, 0. Right? Then 9 times 4 is 36. So we have 6 and then 3. 9 times 5 is 45 plus 3, 48. We have 8 and then 4. 9 times 1 will be 9 plus 4, 30. So we have 1, 3. So you add them, you have 0, 6, 8, 3, 1. So the volume of our cylinder is equal to 13860 centimeter cube. So this is how we arrive at our answer. So this is basically what a solid, finding the total area and then the volume of a solid figure. So one thing that you have to bear in mind is, it's not difficult. What you need is you read, you understand, you know what's the nature of the solid figure, and then you apply your formulas. Okay. Okay. Let's take one through. Okay, one more question. Let's take this figure. We have this figure over here. It's not a solid figure though, but we are required to find the total surface area and other stuff. So this one is 7 centimeters. This one is 90. And then the height here is 20. This one is 50. 48.5. 44.8. 45.2. Then you have A, B, C, D, E. So the question says, find the area. This is not actually a solid figure, but I just introduce it so that when you see something like this, so find the area of the first question, I. That one we dealt with it last two weeks. So that one, find the area of A, B, C, D. So that's the first question. Find the area of A, B, C. And then we know that the area is what? The width times the breadth. So we have the area, which is area of A, B, C, D, will be equal to 90 times 7. 90 times 7. So 9 times 7 is 63, yes, and then so 9 times 7, 0, 63. So we had 3, and then we asked to find the area of, so I this one, give it to yourself. So this one, the area of this will be this times height, half base. So half base times height. And then our base is what's 90. Because when you add these two, we give you 90. What is the same as this? Times the height, 20. So you have 90 times 20 will give you the area of the rectangle. And then the third question says, find the total surface area of this plane figure. So here, what you have to do is you add your I and II. So the area of this plus the area of this will give you the total surface area. So that's how it looks like. So total surface area is not limited to only solid figure, but we can also find total surface area of a plane figure. Okay, so let me give you this, the formula for sphere. Sphere. When you say sphere, sphere is something like in a circular form. So sphere. So when you pick the globe is a sphere, something like this. So let's assume that this is a sphere. So we have something like this. It's not a circle. You have 3 dimensions. So this is a sphere. So volume of the sphere is equal to 4/3 pi each. I guess so. No, let's do this. Okay. So this is the volume. So we normally represent volume by variable v. So this is the volume of the sphere. So when you have any question on the sphere, what you need is, this is constant. The pi is given, and then your radius. So you keep your radius, you multiply it by pi times 4/3. This will give you the volume of a sphere. And then let's look at the surface area. So the surface area is 4 pi r squared. So the surface area was derived from the volume, but I will not bother you much with how the derivation, because when you differentiate the volume, then you have the total surface area. So when you differentiate this, that one is not up to your level. So let's take it like this. Total surface area is 4 pi r squared. Okay, so that one is for sphere. Okay, so let's look at one additional common plane figure, a cone, of which you might get some questions on the cone. So So cone is another plane figure. It's another plane figure. Sorry, a solid figure. Cone is a solid. So this is how cone look like. So this is a cone. So the tip here is the apex. The apex, and this one is a lateral height or slant height. Either lateral height or slant height. And then the base is a circle. So you have this circular part. And then you have a radius. And this is the height. So to find the total surface area, what we have to do is we first find the area with slant height, which is this and that. So the area of slant height is the area of slant height is this. You multiply this height by the radius times pi. So at the end of the day, you get pi times, let's say this one is r, which is the radius, and then the slant height, let's label it L. So you have this. So this is the area of the slant height. So after getting this area, then you find the area of the circle, then you add them. So when you add them, then you have your total surface area. So the area of the circle we all know, which is pi r squared. So for us to get the total surface area, we add two areas. So total surface area, of a cone is given us. So let's say total surface area is equal to this slant height, which is pi r L, where L is the slant height, plus pi r squared, which is the area of the base. So this is total surface area. You can decide to break it down. So you have pi r into bracket L plus r. L. So this is total surface area. Okay, so I would like to end today's lesson here, and I hope today you've learned a lot. So what we basically did is we are trying to find the volume, which is the total space inside that particular solid figure, and then we try to look at the total surface area, which is the total area of the outer area of the solid figure. And then we came out with some formulas and some derivation of total surface area and the volume. So try to work more examples, pick all past questions under solid figure, total surface of solid figure, and then the volume, and try to apply these formulas and then solve more questions. That would be the best option, because the more you solve, the more you have upper hand and confidence. You know that what you are doing is correct. You don't need to stretch your legs and then your necks to look at what others are doing. So believe yourself, work hard, everything will be fine. Okay, bye bye, next week. Yeah.